Hi. So everybody remembers the Will Smith starrer I, Robot movie of 2004, where everybody had a self-driving vehicle. Everybody is talking about the hottest buzzword around the automobile industry, apart from flying cars, is self-driving cars. So what are self-driving cars? They are an amalgamation of computer vision, Internet of Things, cloud computing, artificial intelligence. So how can we make self-driving cars happen using various currently available AWS technologies? So let's first see what are the features with these self-driving vehicles that are being offered or supposed to be offered in the near future. So they are going to be like driver or the user's mood analysis, health analysis, temperature analysis, automated music player, automated polarization of all transparent surfaces such as the windows, the sunroofs, and they will be offering automated user anthropometry. There would also be a conversational artificial intelligence. So some are already launched, some are going to be launched in the near future, as I said earlier, and let's understand what are some of these features. Automated user-based anthropometry, as I said earlier, will adapt the seating to your body contours to provide you the maximum comfort based on your body and your current driving terrain. So the goal would be to make the seating offer the maximum comfort to the passenger. Conversational artificial intelligence, rather than you saying, "Hey Alexa, hey Siri," or Cortana, the artificial intelligence will offer you a genuine human conversation without requiring cloud connectivity. In case of a collision or any other emergency, the required services, whether it is paramedics, cops, or the fire department, they can automatically be called by the artificial intelligence. So how do we do it? So basically what happens is all the sensors which are on board the vehicle, they feed data to a service which we call AWS Greengrass. Or you can have, for certain sensors, you can have the IoT core installed, but Greengrass is a far better solution. Now all the data collected gives a machine learning output back to the sensors without requiring any connectivity to the cloud. But in case you have connectivity, then in that case a Lambda function fires and that connects to AWS, where the Kinesis video streaming is used to extrapolate that what the decisions are required, what decisions have to be taken. They validate the data that what decisions have been taken are correct, and the machine learning educates, it helps the AI to learn using deep learning algorithms. We also use data streams, which is a part of AWS Kinesis analysis program. At the same time, we would be using AWS Rekognition and AWS Polly. Now, why would we be using Polly is that in case there is an emergency and emergency response is required, so Polly, what it does is it converts text from the artificial intelligence into audio call, and that is stored inside an S3 bucket. And then we use service something similar to, or either Twilio, which then calls the emergency response teams automatically. We all know about the current fingerprint recognition in phones for the last couple of years. We have face detection and we have cornea recognition coming up in technology. We all know how computer vision helps these vehicles to drive. So how would computer vision help in user authentication or inside the vehicle? So we would have something called touch biodata in the near future, which would let the micro camera sensors to read fingerprint and hand contour data using either open computer vision or neural algorithms like YOLO to detect which user is driving or riding, and let the artificial intelligence do a SSO, which we normally call a single sign-on, and let the cabin environment adapt to that user's needs. So we would be again be taking the input from all the sensors, and we would be using algorithms like open computer vision or newer algorithms like YOLO, as I said earlier, and we would be inputting all the data to onboard system, which is going to be Greengrass in case of AWS, and then it'll be doing all the machine learning compute and telling that the artificial intelligence that who is the user. In case there is connectivity, again a lambda function would fire, and it will provide all that data input to the AWS cloud and let it analyze that who the user is and what input has the user provided. So here's something new. We all know that for the last couple of years there has been talks going on, there have been concept vehicles where manufacturers have tried to remove all that clunkiness which is currently inside the cabin. So there are air vents, there are onboard entertainment systems, there is obviously your steering wheel which has so many buttons on board. So here's what's going to happen in the future. Everybody has seen the Iron Man movie, and everybody knows about the Tony Stark's Jarvis computer and its interface. Now what actually that interface is what we call something haptic holographic 3D interface. So what it does is it projects in 3D space all what needs to be shown to the driver. So all your meters, all your odometer, your screens which shows that where you are supposed to be going, your Google Map directions, your lane changes, your current speed accelerometer, everything is going to be taken away. So what there is going to be called a 3D holographic haptic interface. So what it is going to do is it's going to be augmented reality plus 3D holographic haptic interface. So now you want to see that which lane your car is going to be. So it'll be projected on your screen. So that's augmented reality. So everybody knows about Pokemon Go. It is the biggest hit. It was the biggest hit when it launched. But this technology is, to my knowledge, is about 40 years old. We used to use these in all fighter jets all across the world's air forces to show the pilot in real time where exactly he or she is flying and what all data of the aircraft needs to be projected. So it all used to be shown on a small screen. Now, in this case, it'll be on your windshield. Plus, if you want to play music, if you want to talk to your conversational AI, or you want to have a private conversation with one of the passengers and you want the artificial intelligence not to listen to, so now rather than touching a screen or rather than touching a button, you can do that in the air. So you just wave a hand and you will see that the mute has been activated in thin air. So everything will be projected in thin air. That's the new technology which is coming up. As I have said earlier, there are two parts of a smart car program. One is the onboard system and another is the cloud backend. So now we need to understand that how can we implement the entirety of the solution using cloud technologies. Here's how we will start. So sensor data input will be processed on board by computer vision algorithms, machine learning algorithms, basically by Greengrass. Then cloud compute, that is used for using a couple of different programs which we put together to find out the best possible solution. So first is Polly. It converts text into speech. So that will be used for your conversational artificial intelligence to talk back to you. Sumerian forms the backbone which will be used to create and run virtual reality or augmented reality applications, so that they can adapt and they can put in front of you 3D graphics. So all your tactile interfaces, whatever is being shown, as in the lane changes, probable collision detection, and braking and everything, will be shown using Sumerian. Then there's another technology which we know as Lex, which converts speech to text, and it recognizes the intent of that text. So when we talk back to our conversational AI, it will help to convert all our speech patterns into text so that the logs can be created. Along with that, either we will be using LiDAR, which is laser radar, or we will be using FMCW technology, which stands for frequency modulation continuous wave. So either of these technologies which we use, they give us the environmental cognizance that what is coming up, whether the car in front of us is stopping, it's braking, it's changing a lane, is there another vehicle which is overtaking us, is that going to be a larger vehicle, or is it going to be a pedestrian, or is it going to be a bicycle, or what? So currently all the programs are running on open computer vision algorithm, and in future we hope that they'll be running on YOLO, which is you only look once, and we will be running a couple of infrared and other proximity sensors. So all the sensors put together, they are collectively called as IMUs. We would also be using recognition, which is basically for image and video analysis. We would be using Amazon TimeStream or probably AWS IoT Analytics, and also Kinesis TimeStream, DataStream, and video streams. So either of these platforms, whichever we are going to use, they are basically going to be used to analyze the environmental data which is being fed in by the LiDAR and FMCW technology and the cameras and all those sensors. When all of this put together comes along, you have your next generation future self-driving vehicles there in your hand. For any questions, you have the details at the end. My number is +1 832 308 9321, and this is AB Singh. Thanks.